Welcome to Gate Path. Today's lecture will be on complement of binary, octal, and hexadecimal. First, let's start with binary. For binary, there is ones and twos complement, and ones complement. Let's take an example for it. So for ones complement, we have to just reverse the digits of binary. One will become 0, 0 becomes 1, 1 becomes 0, and so on. So this will be the ones complement, and if you just add one integer, it will become the two's complement. 1 plus 0 is 1, then 1, 0, 1, 0, 0. This will be the second's complement or two's complement. So this is a ones and twos complement for binary. And there is another method which is similar for binary, octal, hexadecimal, decimal, or any other base. Let's get into that method. That will be the n minus 1 complement method. So n represents the base value for binary 2, for octal it is 8, for hexa 16, for decimal 10, and so on. So if you just minus 1, then it will become 1, this will become 7, this will become 15, and this will become 9. So for one's complement, we're going to use this n minus 1 complement method. Let's take the same example on the left side for binary. 1, 1, 0, 1, and 0, 1. In n minus 1's complement method, all we have to take is the max value. I mean, for binary, the max value is 1, and you have to represent that max value in every bit like this: 1, 1, 1, and 1. Now we have to do is subtraction here. 1 minus 1 is 0, 1 minus 0 is 1, 1 minus 1 is 0, 1 minus 0 is 1, 0. If we observe, this is the same value that we had derived. And again, for 2's complement or n's complement, for base 2, that becomes 2's complement. Add 1, this will become 1, 1, 0, 1, 0, and 0. So this is the same value in the left side and in the right. Let's take an example for octal, and you have to practice the hexadecimal example on your own, so the method is similar. We will be only discussing octal now. You can practice by doing decimal or hexadecimal on your own. So let's take example any number. Octal range is 0 to 7, so let's take 7, 1, 4. This will be enough for this example. Then 1 for no for n minus 1, which is the 7 complement. For 7's complement, we have to take the max value of the base, which will be 7, 7, and 7. So subtract now. 7 minus 4 3, 7 minus 1 6, 7 minus 7 is 0. So 63 will be the answer for 7's complement. Now add 1. This will become the 8's complement. 6 and 4. With this, we end our lecture for complement of binary, octal, hexadecimal. If you like the video, please share and subscribe with your friends. It will be very helpful for the growth of this channel. Thank you.